Yeah, so when we talk about when we'll use this again, I see a lot of great answers here from business, charting, stocks. Again, we've talked about exponential growth and decay related to stocks, engineering, products. Yeah, there's a lot of great responses to that question. So if we move on, I've seen a lot of you describing our exponential graphs, and you've been accurate in your answers, but you haven't been using the vocabulary that we'll use on the state test and in the future, or the vocabulary that a mathematician might use. So I'm giving you some vocabulary words that I use when I describe exponential graphs, and I would love for you to start using those when you describe our exponential functions, our exponential graphs, and in the future. So take a minute, add these to the vocabulary section of your notebook, and then we will keep going on and start to use these to describe our exponential functions. All right, so when we start to describe the changes that are taking place in our exponential functions, we're going to use this function f of x equals 2 to the x power as our parent function. And we've talked a little bit about parent functions. Again, that is the original function that we're starting with. So any changes that take place to our parent function are what we're going to use these vocabulary words to describe. So again, if our asymptote changes, we would say the asymptote changed from y equals 0 to whatever it changes to. If there was a horizontal or vertical translation, or if there was stretching or shrinking, or if there was a reflection, we would use that to describe what changed from our parent function. So again, we're going to use this parent function throughout the day today. So first thing we're going to think about is what happens when we add a number. So our initial function again is in the form y equals a times b to the x power. If we add or subtract a number c to that, what will happen? So here's exactly what happens, right? I use Desmos to create this wonderful graph here. And if we look at it again, our parent function is in red here. Y equals 2 to the x plus 1 is in black. Y equals 2 to the x plus 5 is in blue. And y equals 2 to the x plus 10 is in green. So if we look at all of these, there's a couple things that I would make sure I state when I'm describing the new functions or the change in our parent function. So if we add a number c to it, first thing I would describe is what happens to the asymptote. And again, that asymptote is the line that the graph approaches but never touches or crosses. So again, in our parent function, that's on y equals 0. And if you look closely, whatever we add or subtract to our function is where the asymptote moves. So if we're looking specifically at 2 to the x plus 1, our asymptote is now on y equals 1. So the entire function shifts up vertically. So again, it moves up vertically. That means it's rising, but the actual graph doesn't shift anywhere to the left or the right. It doesn't stretch or shrink. It just moves or translates up vertically 1 unit. So our asymptote moves up 1 unit, and our y-intercept also moves up 1 unit. So the initial y-intercept was at y equals 1 there, at 0, 1. The new one will be at 2. If we add 5, it'll be up at 6. So the y-intercept is actually 1 more than whatever the c value is here. So those are some of the things I would use to describe it. Take a minute and add what you would use to describe that, and then we'll share out in a minute, and then we'll continue on. And again, it changes the asymptote. Adding a number to the base of an exponential function makes the asymptote either go higher or lower. Yeah, that was a great response, Chloe. So definitely some great ones there. Make sure you're more specific. What changes with the asymptote? What changes with the y-intercept? Is there any stretching or shrinking? Or is there a translation that goes horizontally or vertically? Make sure you're a little bit more specific. All of those are great so far, though. All right, so now we're going to shift and look at the next one here. So now we just talked about what happens when c is added to our parent function. Now we're going to take a minute and talk about what happens when c is subtracted from our parent function. So take a minute, look at these graphs, and think about how you can explain it using that vocabulary. All right, cool. Can I have a volunteer to explain the changes that take place on this graph? Yeah, go ahead, Max. Thanks.
The exponential graph has a vertical shift when c decreases. The asymptote moves down, and so does the y-intercept.
Yeah, exactly. Thanks, Max. Yeah, the asymptote. So yeah, clearly the asymptote and the y-intercept move downwards. So we talked about when c is added and the graphs shift upwards. Again, this one, the graphs shift down now, and the asymptote is on whatever c is, so -1, -5, and -10 here. And then our y-intercept again changes as well. So thank you, Max. We'll move on to the next one and have another volunteer share what happens to the next one. I believe that is while a gets bigger. All right, so we are going to switch into our breakout rooms. We will come back together and I'll let you share out on exactly what happens when the rest of these take place. So it'll talk about subtracting a number, it'll talk about increasing your exponent. So again, you're going to use those vocabulary words in your description and make sure you're super specific. So what exactly happens to the asymptotes? Does it move down? Does it move up? Is there a translation? Does it stretch or shrink? So again, be super specific and make sure you're using those words from our vocabulary that we just wrote down.